Last week, I was asked to design a COVID-19 awareness poster for my apartment. The central visual element would be this familiar 3D model of the SARS-CoV-2 virus. Something like this. Or this. Or this. Wait, which one is it? There are pictures of viruses in varying forms and in every imaginable color. I was asking myself, which was the right color of this coronavirus? You will need to watch this till the end because the actual scientific explanation is quite interesting. Keep watching. What I found was that there was enormous creative freedom you could exercise while visualizing this virus. So, why don't I make my own image from scratch? That is when I remembered Puree, my ray tracer in Python. I just completed posting the fourth part of this video tutorial to build a ray tracer using just Python. No additional libraries to pip install, hence the name Pure Ray. So, I never thought I would say this line. Here is how to make the SARS-CoV-2 virus in any color you like. Step 1. Find a reference image. From my research, I found one image from a paper that seemed to be the most authentic image of the virus under an electron microscope. It had a warm color palette with orange and red regions. Select it. Step 2. Mockup in Inkscape. My ray tracer can only render spheres, so it is quite important to know their relative sizes and placements. Any 2D drawing tool can help here, but my preference is Inkscape because I am very comfortable in it. I used only circles to design the mockup while having the reference image close by. I made the core quite simply with a large circle in the center, the surrounding spikes forming a crown or halo-like appearance from which it gets its name Corona are a bit more tricky. The pipe-like stem is faked somewhat by lining up many circles close to each other. The blob at the end of the stem is a medium-sized circle. The colors were picked from the reference image. Step 3. Clone the code. If you have followed the series, then you already have the code. Otherwise, go to GitHub and grab the code until this point. Step 4. Code the virus. I didn't have much time to code, so I had to choose what to remove and more importantly, what to keep. I opened the main.py file and decided that the camera and lights were okay. Added a comment explaining what this is about. Started working on the list of objects. Next, instead of hard coding numbers in code, I set a variable with the value. Should be a constant, but Python doesn't really have constants. I'm changing the red ball to the color of the virus core. Let's move lights out of this to the top. Give it an orange tint for the shiny places instead of white. Now, we need a few spikes around the core. I figured roughly 32 of them looks fine. but what is the position to place them? Imagine this is a flat circle. I know the radius and I have a point on the circle. I can tell you what angle it makes to the center. Then what is the x and y position of this point? Just use this formula. X equals radius into sine of theta, the angle, and y equals radius into cosine of theta. I learnt this formula in high school to draw circles in basic. This is called converting polar to Cartesian coordinates in mathematics. So, let's find out the angle by dividing the full circle, that is 360 degrees, equally by the number of spikes. Then add a small random value for variations. Finally, convert the angle from degrees to radians because Python trigonometric functions work with radians. Each spike is made up of a stem, so I'll need an inner loop to make that stem. Time to use my high school trigonometric formula. I'll remember to offset the spheres slightly so that they overlap each other. Then I'll add that sphere to the objects list. Finally, there's a medium-sized blob at the end of the stem. I'm making a mistake here of putting it inside the inner loop, but it should be outside. However, I'll use the final value of the inner loop variable j so that I know where to position it. This is how the final cleaned up code looks like. Step 5. Render. Running the program with the name of the image will start rendering. I recommend you increase the resolution of the image for a higher quality, but the render time will increase significantly. The poster was also designed in Inkscape. I love posters that are simple and minimal. You could use the rendered image in other places like intros or GIF files. So, what is the color of the COVID-19 virus? The wavelength of visible light ranges from 400 nanometers for violet light to 700 nanometers for red light. This virus is much smaller than that, about 100 nanometers big. Since a virus will not scatter any visible light back to your eyes, there is no concept of color for things that small. Electron microscope uses electrons, so it has up to 0.05 nanometer resolution. But the images it produces are grayscale or artificially colored. You could give it any color and say it is a creative visualization and leave it at that. Don't forget to share your ray traced images on social media. Please remember to tag me, it will make my day. Subscribe now to get more videos like this.